In this video, we're looking at enzymes, and this is part 2. Mr. Philip Kauma here. Let us begin. So what are the objectives for this tutorial video? We're going to look at temperature, which is a factor. So this video is all about the factors that affect enzyme activity. So we're going to look at temperature, we're going to look at pH, we're going to look at enzyme concentration, we're going to look at substrate concentration, we're going to look at inhibitors, and we're going to look at cofactors. So these are the factors that affect enzyme activity. Let us start by looking at temperature. So temperature, as we know it, it's the degree of hotness or coldness. Understand? So when it is cold, something happens to the activity of an enzyme. When it is hot, something happens to the activity of an enzyme. In other words, temperature affects enzyme activity. Let us find out how. So enzyme activity increases with increase in temperature up to the optimum temperature. So what we're being told here is that the activity of an enzyme will increase with increase in temperature. So the higher the temperature, the higher the rate of an enzyme catalyzed reaction. So if we look at an enzyme, let's say this is our enzyme, right? As we all know, an enzyme will act on a substrate to form a product, isn't it? So let me draw a substrate binding with this enzyme. So let's say this is our substrate, okay? They are binding. So this enzyme, which is in black, it is acting on this substrate, which is in red, to form a product. Now this process increases with increase in temperature. So this process of this enzyme acting on this substrate will be fast with increase in temperature. So it will be increasing, the process will be increasing, the rate of this process will be increasing as we increase the temperature. That's what this means. So enzyme activity increases with increase in temperature, meaning the process of an enzyme acting on a substrate will increase as the temperature increases. Okay. All right. Now, the optimum temperature is the temperature at which an enzyme works best. The optimum temperature is simply a temperature at which an enzyme works best. So when we're talking about the optimum temperature, it is just a degree at which an enzyme will be so active and it will be so efficient in its activity. It will work at its best at that optimum temperature, at that degree. Okay. So for example, in humans, our temperature, normal temperature, it's 37. Do you know why it is like that? It is 37 degrees because the enzymes in our bodies, they work best at that temperature, 37 degrees. So if your temperature rises, you'll be labeled sick. You won't feel well. Your systems will be slow. The reactions will be slow. Why? Because once the temperature increases beyond the optimum temperature, that will lead to the decrease in enzyme activity. So when we're talking about the optimum temperature, it is just a degree, okay? It's a degree at which an enzyme works at its best. So in human beings, that is 37 degrees. So 37 degrees Celsius, it is the optimum temperature for the enzymes in our bodies, because at this temperature, the enzymes work at their best. So if the temperature is below that, you find that the rate of chemical reactions will be slow. You'll be labeled sick. You won't feel well. That is why they check your temperature. Because if your temperature is high or your temperature is low, that is an indication of sickness. Okay. Otherwise, optimum temperature is the temperature at which an enzyme works best. Now, the activity reduces after the optimum temperature because the enzyme gets denatured and loses its catalytic function. Like I said, when the temperature goes beyond the optimum temperature, we are going to see a reduction in the activity of an enzyme. Let me show you a graph. So when you look at this graph, as we are increasing on the y-axis, okay, we've got rate of enzyme catalyzed reaction. Okay, so on this side we've got the rate, and then on this side we've got temperature. So as we are increasing the temperature, what is happening to the rate of the catalyzed reaction? It is also doing what? Increasing. So if this is 1, okay, let's say 1 degrees, then the rate of enzyme catalyzed reaction will also be, let's say, 1. When we move it to 2, so when you plot, you find that it will also increase this side, let's say 2. So as the temperature is increasing, the rate of the reaction is also doing what? Increasing up to the optimum temperature. So this here is the optimum temperature, of which in human beings we can say 37 degrees. So at this temperature, which is 37 degrees, enzymes are working at their best. But once we go beyond the optimum temperature, what will happen? Here they're saying that the activity, okay, the activity reduces after the optimum temperature because the enzymes get denatured and loses its catalytic function. Now, what do they mean by gets denatured? Let's find out. Enzyme denaturation is simply the disturbance of the shape of an enzyme and its active site, such that the substrate no longer fits in the active site. Hence, the enzyme can no longer carry out its catalytic function. So when we're talking about enzyme denaturation, we're saying that enzyme denaturation will occur once the temperature goes beyond the optimum temperature. So once that happens, we're going to see that the temperature will be too high, which is going to cause a change in structure. So if an enzyme looked like this, right? And then we know that it is specific, isn't it? Because there's a substrate which is going to bind there. Now, if an enzyme looks like this, and then the temperature goes beyond the optimum temperature, then we're going to see that there will be a change in the active site because it will be denatured. So denaturation is just a disturbance in the shape. So instead of looking like this, it will change to looking, let's say, like this. So if this happens, this is now enzyme denaturation, you'll find that the shape of the active site will change, which will make it difficult for a substrate to bind there because the shape has changed. Okay, so that is enzyme denaturation. This is just the disturbance of the shape of an enzyme and its active site, such that the substrate no longer fits in the activity, in the active site. And when that happens, then the enzyme will lose its catalytic function because now it can no longer act on a substrate to form a product. So we're going to see a reduction in the rate of a chemical reaction. So what we need to know here, my students, is that once the temperature goes beyond the optimum temperature, an enzyme will get denatured. Okay, so as you can see, the activity of an enzyme at this point is not as good as the activity at that point. So at this point, the activity is low. Okay, it is low. So when the reactions are taking place at a low rate, then you'll be sick because you're not getting the products that you need from those reactions at a faster rate. So you'll be sick. You won't even feel well. But once it is 37 degrees, like for human beings, for example, you are normal, you are healthy. 37, 38, you are healthy. Understand? So what we need to know about temperature is that the higher the temperature, the higher the rate of the catalyzed reaction up to the optimum temperature. Okay. All right. So that's how temperature affects enzyme activity. Let's look at pH. So pH stands for potential hydrogen. So pH is a measure of how acidic or alkaline a substance is. Okay, so now we're not looking at temperature, we're now looking at acidity and alkalinity. Okay, so when we're talking about pH, it is simply the measure of how acidic or alkaline a substance is. How acidic or what? Alkaline a substance is. So pH values range from 1 to 14. So let me show you the graph. So we've got that pH, so this is the pH that we have. And it ranges from what? From 1 to 14, yeah? And then they're saying that a pH value of 7 is said to be neutral. So pH value of 7 is neutral. And an example of something that has got this pH value of 7 is water. Water is neutral. It is not acidic, it is not alkaline. It is just neutral. So water has got a pH value of 7. It is neutral. Okay. So pH values lower than 7 are said to be acidic. So as we go down from 7, we start approaching 1, something is becoming acidic. So when you look at 1 is a pH value of a substance that is too acidic. It is very acidic. And then when you look at 2 is a pH value which is acidic, but not compared to 1. 1 is more acidic than 2. 2 is more acidic than 3. 3 is more acidic than 4. 4 is more acidic than 5. 5 is more acidic than 6. And then 6 is, so 6 going down acidic. The range from 6 going to 1, those are the numbers for acidic. And then when you reach at 7, that's neutral. So what I'm trying to say is, as you go down from 6 to 1, something is becoming more acidic. Okay, so 6 is less acidic compared to 1. 1 is more acidic than 6. Okay, yeah. But on this other side, as the numbers are increasing, something is becoming more alkaline. Okay, so pH values lower than 7 are said to be acidic, while values higher than 7 are said to be alkaline. So this means that that acidity increases as pH values get lower than 7, and alkalinity increases as pH values get higher than 7. So as we go higher than 7, something is becoming more alkaline. As we go down less than 7, something is becoming more acidic. So otherwise, pH is the measure of how acidic or alkaline a substance is. All right, so we now know about pH. Let's find out how it affects. Okay, so let me even put up the graph. So the pH value at which a given enzyme works best is called the optimum pH. So in this case, it's not optimum temperature, but it's now optimum pH. So optimum pH is just a pH value at which an enzyme will work at its best. So this pH value can be 5. This pH value can be 7. It can be 9. It can be 11. Otherwise, a pH value, it is the optimum pH. It is the pH value at which an enzyme will act at its best. So values lower, okay, or higher than the optimum pH, they will lower enzyme activity. So we know that pH values range from 1 to 14, right? And we know that 6 going down acidic, and then 8 going up alkaline, isn't it? So let me give an example of the stomach. The stomach is said to be an acidic environment. Your stomach is an acidic environment. So what does that mean? That simply means enzymes in your stomach, they work best in an acidic environment, isn't it? So keep that in mind as we continue reading. So we're saying that values lower or higher than the optimum pH lower enzyme activity. And then the optimum pH varies from enzyme to enzyme depending on the enzyme's natural occurrence. So as I was talking, the enzymes in the stomach, they work best in an acidic environment. Acidic environment, because the stomach is an acidic environment. So the optimum pH for the stomach is around 1.5 to 3.5. Okay, 1.5 to 3.5, within that range. So each enzyme has got its own optimum pH. So if you look at the enzymes in the stomach, they work best in an acidic environment, isn't it? So you may find that an enzyme has got the optimum pH of, let's say, 3.5. Meaning 3.5 is the optimum pH. At this pH value, an enzyme is acting at its best. So we can say that, okay, this is 3.5. This optimum pH is 3.5. So meaning if we are less than 3.5, the activity will be low. Okay, if we are less than 3.5. And if we go beyond 3.5, the activity again will be low, because when you go beyond the optimum pH, we know what happens, isn't it? But if it is at that optimum pH value of 3.5, the enzyme will act at its best. So once you go lower or higher, the activity of an enzyme reduces. So it needs to be at the optimum. And like I said, when you look at the stomach, it has got a range of 1.5 to 3.5. That's how acidic the stomach is. So the optimum pH is around that range, 1.5 to 3.5. But what we should take note of here is that the optimum pH, it is the pH value at which an enzyme works at its best. And then when you look at small intestines, the small intestines, that's an alkaline environment. It's an alkaline environment. So meaning the enzymes that are in the small intestines, they work best in an alkaline environment. So you may find that, okay, let's say, what is the optimum pH for the small intestine? Well, it ranges from 7 to 8.5. So when you look at 8.5, it's alkaline. Okay, so if we're talking about enzymes in an alkaline environment and they've got the optimum pH of 8.5, then we're going to write 8.5, right? So meaning if we are below 8.5, the activity of an enzyme will be low. And then if we are above 8.5, again, the activity of an enzyme will be low. But if it is at the optimum pH, then it will be high. Because at this optimum pH value, which is 8.5 in this case, an activity is working at its best because that's the optimum pH for an alkaline environment. So what you need to know here, there's nothing confusing. What you need to know is this. When we're talking about optimum pH, it is either that optimum pH is an acidic value or that optimum pH is an alkaline value. So if it is an acidic value, then we're going to have numbers less than 7. If it is an alkaline value, we're going to have numbers more than 7. And if an enzyme, its natural occurrence is in an acidic environment, then the optimum pH will be values that are for acidic. So let's say 4. 4 is a value for acidic. And if an enzyme is occurring in an acidic environment and that is its natural occurrence and it has got the optimum pH of 4, then 4 is the optimum pH. Meaning if you are less than if we go less than 4, the enzyme activity will decrease. If we go more than 4, again, the enzyme activity will decrease. But if we are at 4, the enzyme activity will be at its best. Okay. Likewise, if we have an enzyme which occurs in an alkaline environment naturally, then we expect the optimum pH value to be numbers above 7. So we can say, okay, 10. So 10 is the optimum value. It's the optimum pH for an enzyme which is occurring in an alkaline environment. So if we go less than 10, the activity of that enzyme would decrease. If we go more than 10, the activity of an enzyme will decrease because it just needs to be at 10. All right, so that's all about pH. If you've got questions, feel free to ask during our night discussion. Enzyme concentration. How does enzyme concentration affect enzyme activity? So, the rate of an enzyme catalyzed reaction increases with increase in the concentration of the enzyme and remains constant when there are no more free substrate molecules for the enzyme to act on. So what does this mean? This simply means the higher the number of enzymes, the higher the rate of reaction, until all the available substrates have been acted upon and we no longer have substrate for the remaining enzymes to act on. Therefore, the reaction will remain constant. Let me explain. So if we have 3 substrates, right? Right now, nothing is happening. No reaction is taking place. But immediately we introduce an enzyme, right? Let me change the color. Let me change the color. So we've got 3 substrates, right? 3 substrates. At this point, nothing is happening. If we introduce an enzyme, then the reaction will start taking place, because this enzyme will bind with one of these substrates. So maybe it will bind with this one. So once it starts acting on this one, then the rate of the reaction has started. So when we introduce another enzyme, then we are going to increase the rate of the reaction, because we have added another enzyme. So the rate of the reaction will increase. So this one will start acting on this other substrate. Again, when we introduce another enzyme, again the rate of the reaction will increase, because this will start acting on this one. But when we introduce another enzyme, nothing will change, because there is no other substrate available for this enzyme to act on. Therefore, the rate of the reaction will remain constant. Are you following? That is why we're seeing how the curve is going. Okay, as you can see on our curve, as we are increasing the number of enzymes, right, the rate of the reaction is also increasing up to a certain point. So in this case, up to 3 enzymes. So after 3 enzymes, when we introduce the 4th enzyme, nothing will happen. When we introduce the 5th enzyme, nothing will happen. When we introduce the 6th enzyme, nothing will happen. Why? Because there are no other substrates for these enzymes to act on. So the reaction will be constant. So when we just reach per 3, that's all, because the 3 now have occupied all the substrates. So when we introduce other enzymes, nothing will happen. Are you following? So if we introduce the 4th enzyme, nothing will happen. If we introduce the 5th enzyme, nothing. The reaction will remain constant, because the other enzyme, the new enzymes that we are introducing, they are not finding any available substrate for them to act on. So the reaction will just be constant. So that's how enzyme concentration affects enzyme activity. So the rate of an enzyme catalyzed reaction increases with increase in concentration of the enzyme and remains constant when there are no more free substrates or free substrate molecules for the enzymes to act on. I hope that is clear. So that's how enzyme concentration affects enzyme catalyzed reaction. Yeah. Substrate concentration. How does substrate concentration affect the rate of a catalyzed reaction? All right. So the rate of an enzyme catalyzed reaction increases with increase in the concentration of the substrate, and levels off remains the same or remains constant when all the enzyme active sites are occupied by the substrate molecules. Additional substrates have nowhere to fit on the enzymes. Same explanation. So if we have 3 enzymes, right? These enzymes are free because they're not acting on anything. So if we introduce a substrate, then this substrate will be acted upon by one of these enzymes. Okay? So the reaction has now started. If we introduce another substrate, there's an increase in the rate of this reaction, because this enzyme will act on it. Again, when we introduce another substrate, this enzyme will act on it. But if we introduce another substrate, it will find that the active sites are occupied by these other substrates. So it won't find any free enzyme which can act on it. Therefore, the reaction will remain constant. So meaning, after three substrates, if we introduce another substrate which is a 4th, nothing will happen. Nothing will happen. So this is 3. If we introduce the 4th substrate, nothing will happen. If we introduce the 5th substrate, nothing will happen. Why? Because there are no free enzymes to act on these substrates which are being added on. So that's why they're saying additional substrates have nowhere to fit on the enzymes, because the enzymes are already occupied by the substrate molecules. So that's how substrate concentration affects the rate of an enzyme catalyzed reaction. All right, let's look at inhibitors. What are inhibitors? So an enzyme inhibitor is any substance that slows down or completely stops enzyme activity. So inhibitors, what they do is they slow down or they completely stop enzyme activity. So now, competitive inhibitors bind to the active site of an enzyme and block the substrate from binding there. That's what competitive inhibitors do. They will bind on the active site, okay, of an enzyme and block the substrate from binding there. In other words, competitive inhibitors will compete with the substrate for the active site. So you find that the competitive inhibitor has got the same shape with the substrate, and they will start competing for the active site. So if we have our enzyme with this active site, you find that we're going to have an inhibitor, okay, and then we'll have a substrate. So the substrate will also look the same, and these two will start competing for the active site. They'll start competing for the active site. So what this inhibitor will do is that it will bind on the active site. Once it binds, it will prevent the substrate from binding there. These are competitive inhibitors. And then non-competitive inhibitors will bind to the allosteric sites of an enzyme and cause the shape of the active site to change so that the substrate fails to bind. So when you're looking at non-competitive inhibitors, so we have an enzyme there. So for non-competitive inhibitors, what they do is that they're going to bind on the allosteric site. So you will find that a non-competitive inhibitor has got a shape like that. Okay, so this non-competitive inhibitor, what it will do is that it will bind on the allosteric site. Once it binds, it will cause a change. It will cause a change in the active site. So maybe it will more like squeeze the enzyme, causing or altering a change on the active site, making it to look maybe something like this. Okay, and then you find that now it is impossible for a substrate to bind on the active site. Why? Because this non-competitive inhibitor has altered the shape of the active site, making it impossible for the substrate to bind there. So that's what inhibitors do, and we've got examples like poison. Poison is an example of an inhibitor. So all metabolic poisons are examples of enzyme inhibitors. All right, so we're almost there. Cofactors. What are cofactors? So an enzyme cofactor is any non-protein substance whose presence makes an enzyme active. Okay, so these, what they do is that their presence will make an enzyme to be what? Active. So organic cofactors are called coenzymes, e.g. vitamins. So vitamins, they will make, you know, your enzymes to be active. Their presence will just make an enzyme to be active. That is why we need vitamins. Okay, so inorganic cofactors are called activators. So inorganic cofactors are called activators. When you hear this term inorganic, it simply means they do not contain carbon. So inorganic cofactors are called activators. E.g., we've got mineral salts. So mineral salts will also activate enzymes for them to act at their best. Otherwise, that's what cofactors do. There's nothing much here. A cofactor is just any non-protein substance whose presence makes an enzyme active. All right, my excellent biology students, thank you very much for watching. This is the end of part 2. Watch out for part 3. Subscribe to my YouTube channel if you haven't yet done so. I will really appreciate. See you in the next video. Stay blessed.